Did you know rockets use Newton's third law to launch into space? It's true. Every action has an equal, opposite reaction. This principle governs everything from walking to space travel. So, what exactly are the laws of motion? They are the fundamental rules that govern how objects move. These laws are super important for NEET because they form the basis of mechanics and are tested frequently. Let's start with Newton's first law, also known as the law of inertia. This law states that an object at rest stays at rest, and an object in motion stays in motion with the same speed and direction unless acted upon by a force. Think of a ball rolling on a perfectly smooth surface. It would keep rolling forever if there were no friction. Inertia is the tendency of an object to resist changes in its motion. The more massive an object is, the more inertia it has. So, a heavier object is harder to start moving or stop once it's moving. Next, we have Newton's second law, which relates force, mass, and acceleration. The net force acting on an object is equal to the mass of the object multiplied by its acceleration. This means that if you apply a larger force, you'll get a larger acceleration, and if the object has a larger mass, you'll need a larger force to get the same acceleration. Newton's second law is expressed as F equals ma, where F is the force measured in newtons, m is the mass measured in kilograms, and a is the acceleration measured in meters per second squared. Use this formula whenever you need to find the relationship between force, mass, and acceleration. Now, let's talk about Newton's third law. For every action, there is an equal and opposite reaction. This means that if object A exerts a force on object B, then object B exerts an equal force in the opposite direction on object A. Remember, these forces act on different objects. The action-reaction pair can be represented as FAB equals negative FBA, where FAB is the force exerted by object A on object B, and FBA is the force exerted by object B on object A. It's crucial to remember that these forces always act on different objects, so they don't cancel each other out. Here's a key point: action and reaction forces never act on the same object. This is a very common mistake students make, and examiners love to test this concept with tricky questions involving multiple bodies. Drawing free body diagrams will help you avoid this trap. Let's solve a problem. A 2 kg block is pushed with a force of 10 N. What is the acceleration of the block? To solve this, we use F equals ma. So, 10 N equals 2 kg times A. Solving for A, we get equals 10 N divided by 2 kg, which equals 5 meters per second squared. Think about walking. When you push backward on the ground, that's the action. The ground then pushes you forward, that's the reaction. This is Newton's third law in action, allowing you to move forward. Understanding this is crucial for analyzing systems with contact forces. Here are some exam tips to keep in mind. Always draw a free body diagram to visualize the forces acting on an object. Pay close attention to the direction of the forces. And remember that F equals ma applies to the net force acting on an object. Let's quickly summarize what we've covered. Newton's first law is about inertia, which is an object's resistance to changes in motion. Newton's second law, F equals ma, relates force, mass, and acceleration. And Newton's third law describes action-reaction pairs acting on different objects. All of this, AI-powered notes, doubt solving, and practice tests for laws of motion, is available for free on Synapse. Study smarter, not harder. Start learning for free today at synapse.omups.in. Master laws of motion for NEET. Please subscribe to our channel to get more content like this. Visit synapse.omups.in and start learning for free today.